So good morning all. Welcome to day 5 of OpenStack. Today we will be talking about the very important call flow of OpenStack. So let me quickly jump to the main topic. Okay. See, last week I explained you about the OpenStack architecture, and the most important thing which I explained you was about triple O. Triple O is a very important architecture in commercial OpenStack environment, and we are going to focus on the triple O deployment architecture only in our classes. So also I explain you about the services which runs on each type of node, whether it is a controller or compute. So today I'll just explain you on short in a brief, like what how exactly this triple O architecture, which we call it as OpenStack over OpenStack. This is very important from interview point of view. So if any one of you are going to appear for any of the OpenStack related job profile, so this is an important topic. And also if you are working in OpenStack, so for you also it is very important topic. So see, when we say OpenStack over OpenStack, so how exactly the architecture looks in the customer environment. So we first say that the very first node, so this is a single node. So here if you see on the right side, I have mentioned that triple O under cloud, in a short form abbreviation I am calling it as UC. So UC is a single node basic OpenStack. So here you can see this is your single node OpenStack. So if you are deploying a data center of OpenStack, so the very first node which you create is the under cloud, and this under cloud is a single node OpenStack, and it has all the important services of OpenStack. It has its own Nova, Neutron, Glance, Keystone, Horizon, Heat, Cinder, Swift, Ironic. But please note that these services are not going to be used for customer point of view. So for example, if you want to launch an instance of VM, or you want to create a network, or you want to create a volume as a user, so you are not going to use this under cloud. This under cloud is specifically meant for the life cycle management of your actual OpenStack environment. Okay, so this is your first OpenStack first node, which you call it as under cloud. Underlining OpenStack, here you can see some customer or vendor, they relabel it as director or different type of names you may find. Virtual infrastructure manager also, there are so many names given to this under cloud node. Now let's see what is the actual OpenStack. So your actual OpenStack basically comprises of your controller nodes. So we have three controller nodes, as I showed you in previous slide. Also in the standard architecture we have three controller nodes. So here I'm just depicting the controller functionality. So in controller, what services of OpenStack you have? So you have Keystone, you have a part of Neutron, that is a management part of Neutron. You have management part of Nova. You have Glance, Cinder, Swift, Manila, Heat, Horizon. Other than that, you can have other optional services also, like you can have telemetry, you can have other different services. The compute host basically has your Nova hypervisor, it has Neutron. If in your architecture you have a separate networking node, then this Neutron will go to that particular node. But usually we find that in the compute node only we have the Neutron services. So Neutron, this is actual Neutron which is going to provide networking to your VMs. So these compute hosts are going to actually host your virtual machines. This is your Ceph storage. So you have external storage, you have a Ceph software. I mentioned you last week also. Ceph is an open source software which provides these storage as a service. Storage as a service. So storage as a service, like we have three type of service I mentioned last week also. One was your block, then your object, and third was your file system. So these three type of services are exposed to OpenStack. So to your compute nodes, it is exposed. So self storage is connected to your compute nodes. So whatever instance, volume, or object storage, or your file system you're going to use in your virtual machines is actually going to come from this external self storage. So it is a separate server with hard disk. So they have the external hard disk connected, and then you have the service coming to your OpenStack. This is called as your overcloud. So I hope from here you are clear what is under cloud. Under cloud is a single node OpenStack, whereas over cloud is a combination of different hosts which has controller, compute, and self storage. And this has the services of OpenStack. So when we say services of OpenStack, so these are the services of OpenStack. These services you can see is divided. So in compute you don't find Keystone, you don't find Glance, you don't find Cinder, Swift, Horizon, Heat, any of the services. Why? Because this is being hosted by your controller. On compute you only see what the hypervisor service, which is provided by Nova, and then the Neutron networking parts. Only two type of OpenStack services run in compute node, and then you have the self storage. So this is called as a over cloud. Now here you can see it is under cloud is responsible for life cycle management of your over cloud. So this is again an important question that people may ask, that why do we need to have two OpenStack? Like you already have an OpenStack. So here you can see like you have one OpenStack. So similar kind of deployment you can do in other nodes also, and then why there is a need to have two OpenStack? So see what happens. This is your single node OpenStack. Here you can run services and you can provide services to your client, but provided it is going to be a commercial system, so it has to be highly reliable and it has to be scalable also, because the number of instances which are going to be hosted on your OpenStack will be huge. So you cannot say that in a single server, single physical server, I have a capacity to host n number of virtual machines and provide storages and other things. So that's why you need to have multiple nodes cluster. And if you have a multiple node cluster, then definitely questions come how you are going to manage the cluster, because if you have 10, 20 or n number of cluster, definitely someone need to take care of the cluster also. You have one thing is the functionality of the OpenStack services, and second part is the administration management of the complete OpenStack. So that's why we have a role called controller, and then we have a role called compute, which actually host your instances, and controller basically manages your OpenStack commercial. So that's why the role got divided, and the first three VMs we call them as controller, and they have only those services which are required for controller point of view. But if you come to compute, so we don't overload our host, our compute node with extra services. So why do I need to host like Keystone or Glance or Cinder or Swift or Manila or Heat or Horizon in compute nodes? Because this compute node is basically going to launch a virtual machine. So I don't want the physical host to be loaded with extra activities, because in turn it is going to impact the performance of your virtual machine. So as a standard architecture, this type of design has been done. Life cycle management, as I was saying, so life cycle management means what? See, when you say life cycle management, so uh, just a second, let me see. Okay, so I thought I'm on mute. Okay, so life cycle management, when I say, so see, life cycle means this complete architecture I want to manage for the whole life. Whole life means that suppose tomorrow I want to do expansion, or I need to put any of the node under maintenance. So suppose if your controller is having some issue and you want to put it down as a part of maintenance, or any you want to have delete your compute host due to reason, or you want to expand your capacity. So these type of life cycle related activities can be easily done with the help of this undercloud. So this undercloud basically is managing your complete architecture. So if you want to delete or add any number of hosts, you can do easily with the help of this undercloud. If you want to upgrade your OpenStack, so suppose you want to go with the new release of OpenStack, that you can do easily with the help of this undercloud. So this OpenStack is not given for user. So any user, if it is using your OpenStack environment, it is not going to use the services from this undercloud instance. It's not going to connect this host for launching any VM or creating a network or creating an or like uploading an image. No, this is going to manage or do the life cycle management of this complete architecture. As a user, if some user is connecting to your OpenStack as a commercially, they will come to this particular horizon, and this horizon is being hosted on the controller node. So I hope this is clear to you. Otherwise we will take it in question and answer section and the end of the session. So now I'm moving ahead with very important topic, that is about your communication of the OpenStack services. See, these are the services which I have listed, or these are the services which I'm discussing with you, but you know Even I showed you on the couple of days before that the OpenStack landscape. If you talk about OpenStack offering, so it has huge portfolio. It has a very huge portfolio. It does not only have like Nova, Neutron, or Swift, Cinder, Manila. It do have some additional services also. But when we work in our OpenStack, I mean the customized one, when we work on our company OpenStack, so definitely we may find some of the services or we may not find many of the services. But to us as a user, it is important that we try to learn or understand most of the services. Here, when I'm discussing with you about OpenStack services, so I usually go with like 6 or 7 important services. So these are the services which are responsible or important for you to deploy an OpenStack. So here you see the services which I have listed are a limited one. Limited means which is required for your day-to-day OpenStack operation. But suppose if you have an advanced OpenStack and you increase your number of services from the OpenStack, from the community OpenStack portfolio, you increase number of services in your customized OpenStack, definitely the number of services or the flows will increase here. So when I say flow will increase, doesn't mean that Horizon, like if you say Nova will change its functionality. No, Nova still remains same. Nova still remains same. Only thing is that you have some more functionality added in your OpenStack. So here I'm discussing only limited services which are important for us to understand OpenStack at the moment. So here you can see the division which I have done. So very important thing in OpenStack is that you have a number of services and these services are designed on a standard principle. So standard principle means that because these services need to talk to each other, and suppose if you don't have a queue system, so suppose you don't have any mechanism, standard mechanism for the services to talk, then eventually this complete architecture will land in a mess and everything will be spoiled, because every service need to talk to each other for different purpose. So you have Keystone, you have Horizon, you have Neutron, Glance, Cinder, Swift, Manila. These are the at least components you know, which are a generic one, and they talk to each other very oftenly. Means they talk to each other. Nova API, Nova scheduler. This I will discuss in detail in the next slide. So you don't need to worry about what these services are actually. So I will discuss them. But here my point to explain is that these services need to talk to each other, and you need to have a standard mechanism where these services can talk to each other without any hassle or without any loss of message. Because if you lose any of the message, definitely your end-to-end flow is going to be impacted. So suppose if you're launching an instance from an OpenStack GUI, and if any of the flow gets disrupted or loses its transaction state, definitely your complete end-to-end flow is going to be impacted. Your instance will not launch. Even though everything is perfect, still your instance will not launch. So it is very important that we have a standard mechanism. So here OpenStack has followed queuing, messaging queue technology, and it is from one of the open source software that is called RabbitMQ. So RabbitMQ is an advanced messaging queue. It is not mandatory to have RabbitMQ in your OpenStack, but you will find mostly that RabbitMQ is being used as an advanced messaging queue in OpenStack softwares. You can check this particular thing in your local, in your company OpenStack, whether you have RabbitMQ or not. But this is the one which we find in most of the places, and community OpenStack supports this RabbitMQ as a default. Now let's explain what exactly this RabbitMQ is. So this RabbitMQ is basically a kind of a queue technology. Its purpose is only to receive request from service and then pass that request to another service for to the destination node. So suppose your Keystone want to talk to Neutron, or let's take it in a reverse order. Neutron want to talk to Keystone. So here Neutron cannot directly talk to Keystone. It will send request to messaging queue, and messaging queue knows that this is going to be for this particular destination. So it is going to send request to Keystone, and whatever response is coming from Keystone will again go back to Neutron. So this is how one service talk to each other. This is just an example like how services talk to each other in OpenStack. Now let me discuss a very important slide for VM instantiation flow. So this is very important question, and it is very important from interview point of view, that what actually happen when you create an instance in OpenStack. So how is the call flow happening in the OpenStack when you create a new virtual machine? So let's discuss this particular slide in detail because it is very important. And this particular slide is going to take some time because I will explain you each flow one by one. So let me explain, let me go. So you have a use case, you have an OpenStack with you, and you want to create a virtual machine. So when you create a virtual machine, so what exactly happens? See, there are two ways that you can create a virtual machine in OpenStack. Two ways. One is you connect Horizon dashboard, or you connect the CLI, OpenStack CLI of the over cloud. So you have to connect over cloud CLI, or you have to connect to the Horizon dashboard of the OpenStack. These two ways you can create your virtual machine. Now, how the flow happens? So the very first thing, what happens when a user, so suppose you are a user, you want to launch an instance, so you have been given a task to create a virtual machine in OpenStack. So what you do, you first log into the Horizon dashboard, or you open the OpenStack CLI. So CLI, when I say, you talk to the OpenStack over cloud proxy IP, virtual IP. You can say VIP of the over cloud. So when you talk to VIP of the over cloud, or you talk open the GUI, what first thing you do? You log in. So how do you log in? You have username and password. So when you give username and password in the GUI, so what happens on the backend? On the backend, this particular, when you send your username and password, now Horizon is a service in OpenStack and it need to talk to Keystone, because Keystone is the main service which is going to authorize everything. Everything means it is going to authorize your user for connecting OpenStack dashboard. Also, it need to authorize each services when they want to talk to each other, whether you have proper access or not. So what it will do, when this user input username and password, then this open dashboard talk to Keystone. And how it will talk? It will talk with the help of this messaging queue. So it will submit request to messaging queue that I have a user which has given me input username and password, and I need to send this data to Keystone for authorization. Now see, this messaging queue does not read anything inside, so this is just like a postman. Postman doesn't read what is the content inside envelope, it is just meant to deliver the packet. So it is going to take your request and it is going to send to Keystone. Now Keystone is the actual authorization service. It is going to authorize your username and password. Once authorized, it will say that yes, user is authorized, and what it will do, it will provide you an authorization token. Token is sent back to the Horizon service. What exactly is this token? See, this token is basically, you can say, a timer based. Timer based means a session based or token ID, in turn represent the user authorization, that yes, this particular user is authorized, and whatever privilege the user has, the user need to be granted that particular resources. So now in Horizon dashboard, you will see the login page. I mean, after login page, you will see your main dashboard. There you can see only those resources which are allowed for you. So suppose you have roles. So according to your project and your role, you will be getting the type of resources. So suppose if you are an admin, being an admin, you can see admin tab, but if you are a normal user, you cannot see any admin tab. So this is how done, it is done with the help of Keystone. So Keystone does your role based authorization. Role based authorization means whatever role you have been assigned, you will be able to see those resources. And what this authorization token, this one time token generated by the Keystone, will be preserved in this OpenStack this dashboard for the user to do further communication. Because further what happens, I will, okay, let me go with the flow, let me not disturb the flow, but otherwise we will get confused. Now you have the dashboard, so I am explaining you the dashboard flow. So you have a dashboard, you have a template. In that template you have all the inputs required for your VM creation, like you have your flavor, CPU, RAM, hard disk, then you have your volume, image, network, server group, security group, ports, everything in place. So I'm not talking that you are going to create. You have everything in place. Now you are going to launch an instance. So you select, you go to instance, and you create, launch an instance. So when you launch instance, you provide some input values. When you provide input value, then what you do, you select on launch. So when you select on launch, then what will happen? Because this has now received request, now it is going to talk to the Nova. Now here comes the Nova service of OpenStack. Now Nova service of OpenStack has classification. It has internally multiple services. It has Nova API, it has Nova scheduler, it has Nova database, it has Nova conductor, it has Nova compute. In addition to this, it has other services also like Nova VNC, it has Nova console, so many services, but I'm going to talk about the VM launching process. So these services are required for your VM launching. Now the very first service of Nova which is going to accept your request from Horizon dashboard is your Nova API. So the very first request is your Nova API. See, provided you have already user connected to the OpenStack dashboard, you have all validation done, user is already authorized. Now user has already selected template and everything, and then user has selected on launch instance. So when user says launch instance, then Horizon dashboard is going to talk to your Nova API. Nova API is your front end. Front end means it is going to now take care of your VM launching process. Now Nova API will receive request. What actually it receive request? It receives request whatever input you have selected in your dashboard GUI. Then also it will receive the auth token. Why auth token? Because if you don't give auth token to Nova API, Nova API cannot do further communication with any other service. And remember one more important thing, that if any service, the major services like Nova, talking to another OpenStack service like Keystone, Glance, Neutron, Cinder, it need to have the authorization token. Without authorization token, you cannot talk from one service to another service. But if you are talking internally, like Nova API need to talk to Nova scheduler, or Nova API need to talk to Nova compute, or Nova API need to talk to Nova conductor, internally if it need to talk, it does not need the authorization token. But if it need to talk to external service like Keystone, Glance, Neutron, Cinder, definitely authorization token is required. Why? Because this particular Nova API is now need to going to tie, for example, if it is going to talk to Glance, it need to provide evidence that whatever request I am carrying is authorized for that particular user or not. So it should not be like in Nova API you have given some networking information, and that networking information actually is not meant for the user. So it cannot access Neutron in that case. So what will happen? So when this input is received, it goes to Nova API. Nova API has all received your input information, and also it has received your auth token. Now after receiving auth token, it gets the privileges that yes, this particular information I need to update in the further call flow. Now what it will do, it will talk to Nova database. Now if you remember, I discussed about a database in OpenStack. So database in OpenStack is, for example, if it is an open source MariaDB, you can take any type of database. I've just given example of MariaDB. Now this MariaDB is divided into different type of tables, you can say, or yeah, different tables. One is for your Nova database. So Nova DB is a very important because it maintains the instances information. So Nova API is going to check this Nova database, and it will verify whether the information which you have provided, like you have given an instance name, you have selected resources, so is it like that particular instance already created or not. So suppose if instance is already created, definitely it has to reject your request. So from here, your request will be rejected. And in GUI, you will see a prompt saying that instance already exists. But if your instance validation, it will do a kind of pre-check. So in pre-check, if it does not find any information that, yeah, this is a fresh request, it will do entry in database, initial template creation, basically initial DB entry creation. So in your database, Nova API has created your instance information. Now it will proceed further. Now what is the next flow? Now Nova API will talk to Nova scheduler. It cannot directly talk to Nova scheduler, right? Because it need to go to the messaging queue. So it will go to messaging queue and it will talk to Nova scheduler. Now Nova scheduler, what exactly it is responsible? Nova scheduler is basically responsible to provide the host ID, because whatever request you have submitted in the Nova database, it has some expectation that it should be getting launched on specific host. That specific host should be based on some filter, I mean some conditions. So Nova scheduler is responsible to update Nova database with the correct information. Correct information in the sense that Nova scheduler is going to check your Nova database and it is going to apply some rules. So it is going to apply your filtering and weighing mechanism. Filtering and weighing mechanism means that it will check what is the resource requirement and what are the hosts available to fulfill that request. And based on that, Nova scheduler will update this particular table which has your instance information with the host ID where your instance will be getting launched. Now, once this is done, then Nova scheduler will pass this message to Nova conductor. Wait, sorry, it will send to Nova compute, not to conductor, compute. Now, Nova compute need to fulfill this request. Whatever information is there in this database, Nova compute need to fulfill it. But Nova compute doesn't know whether what is the information it is there in the database. So what it will do, it will talk to the Nova conductor, because Nova compute cannot talk to Nova database. This is a security principle of OpenStack, that Nova compute which is running on your compute node cannot talk to database. So Nova compute cannot directly communicate with Nova database. Rather, it will talk to the Nova conductor. So Nova Compute will talk to Nova Conductor to get the information, VM information, like your host ID, flavor. So what we do have in flavor, we have CPU, RAM, and hard disk information. So it will talk to your Nova Conductor, because Nova Conductor knows it can talk to database and it can provide information. So what it will do, it will check all the information and it will provide back to Nova Compute that this is the information you have. This is the every information related to instance. Now this is the main service which is going to create your virtual machine. So if you remember, I told you that Nova API is your front end which is talking to your dashboard. So dashboard communication is happening on Nova API, then Nova API is passing this request to Nova scheduler. Nova scheduler passes this request to Nova compute. Nova compute with the help of Nova conductor gets all the information related to your VM, and then it need to create virtual machine. But in order to create a virtual machine, it needs some additional resources, like it need to get the image which will be created on your hypervisor. This is the actual hypervisor service, but before that it need to have some resources to be fulfilled. Prerequisite, you can say. The prerequisite is your storage, is your image, then your networking and storage. These three prerequisites should be fulfilled, then only hypervisor can create your virtual machine. So Nova compute, now it will talk to your glance. Now it need to talk to glance. Then how it can talk to glance? See, talking to glance can happen from messaging queue. So messaging queue, when it talks, so what it will say, it will provide the auth token. So it will provide the auth token received from the previous request. So it will provide the auth token and it will talk, go to glance. When it goes to glance, now glance does not know that the auth token which you are sending from Nova compute is correct or not, because it may be a case that you are providing a false, providing a false instance ID, sorry, auth token. So what it will do, glance need to double check. So glance will go to keystone. It will check whether this particular auth token is correct or not. So when it says that your auth token is correct, then glance will provide the URI. URI means metadata. See, what is metadata? If you remember, when I explain about the storage services, so I explain you object storage. So object storage is something you have email, I mean your data stored in a library format, and it has a metadata. So this particular glance where images are stored works on the object storage. So object storage means what? The images are stored in some in as per glance data structure. and it has a metadata. So if you want to access any image of the virtual machine, you need to provide the URI, and the URI you can only get when your request is correct. So Nova Compute has provided an auth token. That auth token was validated by Keystone. Yes, this auth token is correct. Then Glance has provided the URI to download image. So it will download image and provide to Nova Compute. This part is done. Now what will happen? Now Nova Compute need your networking. So Nova Compute will use the auth token and it will talk to Neutron, and it will say that please provide me networking services for my virtual machine because I need to fulfill this particular virtual machine request. It will check with Neutron. Now Neutron again, same thing. It will validate whether the auth token which you are sending is a correct or not. It will go and talk to Keystone. Keystone will say yes, your auth token is correct. It will come back and it will provide the networking services. So what networking services actually we provide? Basically the networking means IP. So it will provide a virtual network, basically an IP to your instance. If you have a volume service, if you want to attach a volume to your instance, then what it will do, it will again Nova Compute will send an auth token to sender that please provide me a volume because I need to attach that volume to the instance. Again it will take the auth token and it will go and validate with Keystone, and Keystone will send back to sender. And once the one verified, then it will provide the block storage information for mapping. So once the block storage information is received, so now we have image, we have network, we have sender, all three resources. Now it will come, Nova Compute will come here. It already has from Nova Conductor your CPU, RAM, right? So it has all the information required. Now with all the information, what it will do, it will generate the input for your hypervisor. Now to input, like to generate request, so if you know hypervisor, so you already know that hypervisor has a API, or you can say a language which is used to talk to hypervisor, basically a tool which is called as libvirt. So OpenStack uses libvirt to send command to hypervisor. So this is the actual hypervisor. So Nova Compute will prepare the command using libvirt with all the inputs received from here and input received from here. It will prepare a command and it will send request to hypervisor, and hypervisor will launch your virtual machine. And remember one more thing, this hypervisor is that particular host which you have selected. So suppose if your Nova Compute, if you have 10 compute nodes in your architecture, you have 10 compute. So you are going to have 10 hypervisor. This Nova Compute is going to select the destination as per the information it is going to get from your Nova database. So Nova database suppose says that host ID is 5. So that means this VM should get launched on compute 5. So compute 5 will be launching hypervisor. So hypervisor will be launched on compute 5. So this will create a virtual machine, and then finally request response will go back to your Horizon dashboard that yes, your particular VM has been successfully created and now you can access your virtual machine. And there is one more service which I have not listed here, but that service is called as placement service. So placement service in OpenStack basically is just a kind of an inventory management. Inventory management is basically just to track resources, like you have image, you have Neutron, you have volume, you have your CPU, RAM, consumption, host, which host is actually hosting your virtual machine. Everything is just created as an entry for placement service. So placement service basically tracks resources, that yes, these resources are utilized for this particular type of virtual machine. So this is your call flow for VM creation. This was a very important and you can say quite a lengthy flow also, but this is very important for you if you are working seriously in OpenStack. So with this, I complete my today's session. Today's session was very short, but very important one. Now I want you to ask question to me. So you can ask your questions. Yeah, please go ahead.
Hi Krishna. So I want to know means how RabbitMQ know about the services means how internal communication happen means we have to configure means IP or something that how it detects the services like sender is installed here and glance is there means
Mhm.
so it is internal default or we have to configure IP in RabbitMQ for each services?
Okay, so see, RabbitMQ is part of your controller node. So if we have three controllers, so we have three RabbitMQ. One is active because it is part of PCS cluster. So one more important thing which let me explain you, that the OpenStack architecture which I discussed with you. So let me go. See, here you have controllers. So three controllers. So three controllers are controlled with the help of a PCS cluster, and three controllers, they have database, they have your RabbitMQ, they have your dashboard, they have all the services. So if you see the services running on your controller node, so you already have your what we say messaging queue running, you have your block storage, I mean all the services. So you have, see, you have keystone, your neutron part, nova part, glance, interswifts, everything is running on these controller. So when you say that RabbitMQ, so RabbitMQ here you can see is present in three controller nodes, it is not present in any of your compute node. And these horizon, keystone, neutron, leave neutron, glance, sender, swift, manila, all these services are running in your controller only, except nova and neutron. Nova and Neutron are part of your compute node. So when you say configuration, so when you install your OpenStack, so it is part of your installation configuration that RabbitMQ, it, out of three nodes, it becomes active. I mean, one is master, all three nodes, one is master. So only one RabbitMQ is working at a moment. It is part of your PCS cluster, and it is going to talk to each of the services on the internal IP, because these are already present in same controller node. So this is going to be present on same controller: horizon, keystone, glance, sender, swift, manila. This is going to be present in same controller, so it is going to talk to each of them on the same node. Now talking about nova and neutron, because it is part of your what we say it is part of your external compute node, so it is going to talk to them also, and it has its internal APMI IP system where OpenStack talk to each other on the internal networking, not on any external VLAN. So this is how RabbitMQ communicates with each services.
Okay, thank you.
Yeah.
And second one, one more question. If I have to log in CLI, then can we proceed with the controller node login?
See, talking about control connecting to your
Means
CLI.
I have to launch a project, then means our like VM, then we can we proceed with the controller CLI or
See, okay, let me tell you that the usually in all the projects of OpenStack, compute nodes are never exposed to external world, because they are the actual node which are hosting your VMs. So they are never hosted, never exposed to anyone, so that anyone can connect directly from outside to the compute node. If you want to connect to your node, you have one way, that you come to your controller, and from your controller you can go to your compute, you can do SSH, because in compute you cannot do anything, you have already instances running, you cannot manage your instance from compute node. Management is done by the OpenStack API. So OpenStack API is your dashboard, and the second one is your CLI. CLI has also same, you can say it is connecting to the VIP of one of the controller. So it has HA proxy. HA proxy basically is doing what? You have a single IP of your over cloud, which we call it as IP of your dashboard also. So IP of your dashboard means your one controller IP which is active out of two, out of three total. Two are standby mode. It even has like distribution also. So outside it act as a single IP, and on backend it can distribute request to all three controllers for dashboard service. Now what happens that whenever you connect, so when you connect on GUI you get an interface. From that interface you can do all the operation. But when you connect to CLI, now you can either connect to your controller, so you can come to controller 1, controller 2, or controller 3, or the best practice is that people come to undercloud, and from undercloud they go to overcloud. Why? Because again, in most of the projects I have seen that controller IPs is also not exposed to outside world, because we don't want complete setup to be hacked by anyone. Suppose if somebody connects to your compute or somebody connects to your controller from outside, because it is having your OpenStack database, so controller is hosting your MariaDB or any database, so that person can have direct access to your database, and if person has direct access to your database, it can modify any of your instances. So definitely as a part of security, over cloud is never exposed to outside world except for the dashboard GUI or your CLI VIP. So CLI VIP, when I say, I will show you how exactly that is done, but let me first tell you the logic. So the best way practice is that you come to over under cloud. From under cloud, you can have this IP exposed to your outside world, and then from here you can do SSH to your over cloud. So you can do, there is an alias created which says SSH UC, or you can say SSH, yeah, you can say under cloud. When you connect under cloud, now from here, whenever somebody user want to connect to OpenStack CLI, there is a credential file. That credential file is basically a template which has information, basic information, like it has IP of your dashboard IP, it has your project name, it has your user ID, user password, role, everything. That this is your particular OpenStack dashboard where you have to connect. So when you source that credential file, so you do what you say, simply say source and then your project name. So every project and user has its own credential file. So suppose if I log into OpenStack, so I will get my dedicated credential file. Similarly, if you log in, you will have your own credential file, because my user and your user are different, even though we are working on the same project. So project, and based on user ID, you have a credential file. So you do source credential file. When you say source credential file, it automatically from backend authorize and connect you to the OpenStack dashboard CLI. So this dashboard GUI was using the VIP IP of your controller. Similarly, CLI also connect you to the active controller. So if you have 1, 2, 3, and if your controller is active on one node, you will automatically go to that particular, because you are using the virtual IP. So it will take you to the active controller, and then you can from here only. So you don't need to even log into this node. From here only you say you see source credential file. Then you can simply say OpenStack. There is a new client service provided by OpenStack nowadays. It is called as OpenStack client. OpenStack client. Now that OpenStack client, what helps? It helps you to run OpenStack commands remotely. So from this machine only you can run command. So from here you say OpenStack image list. So when you say OpenStack image list, so OpenStack is your project, main complete project. Image is your service, and then list means you want to just see or create or delete or set or get whatever list. So whenever you give any command, it goes to your virtual IP, that VIP IP of your controller, and it automatically provides you output in this particular machine only. So you don't need to access this over cloud. As a user, you never connect over cloud internally, because it can be like you can say it is very sensible architecture. So we don't want this system to be get hacked by anyone. So therefore, from remote only on CLI mode, you have OpenStack client installed in your machine. You simply say source and your credential file, it will automatically take you to the active controller. And whatever operation you want to do, you want to launch an instance, you want to delete an instance, you want to create a network, you want to create an image, volume, security group, port, protocol, whatever, ingress egress, whatever thing you want to do, you can do from remote only. You don't need to even connect any of the node. So this is how you connect to the OpenStack CLI. Okay.
Yeah, okay, thank you.
See, this is a new service which is supported nowadays. Previously, what was happening? You are right. What you used to do? We connect controller and then we run command. We run command Neutron. We run command for Nova. We run command for Glance. Single API command for each service. We have to run manually command. But again, that thing is that you are exposing your controller to the outside world. That is why we have this triple O architecture. The benefit of triple O is not only restricted to your installation or upgrade, it is also helpful for your day-to-day operation, that nobody connects to your OpenStack environment from outside. Any operation, if anybody want to do, can do from under cloud only. Simply OpenStack client, source credential file, and do whatever operation you want to do. And one more benefit nowadays we have in OpenStack is that previously troubleshooting in OpenStack was very complex, because you launch an instance and if it gets failed, so you have to figure out where exactly is the log file, because so many services running on different nodes, you exactly don't know which particular the host is having that log file. So you have to log into each host. Suppose if you have 64 host big data center, then you cannot log in all 64 nodes just to check whether where is your instance. The one way to troubleshoot was that you get the instance ID, host ID from your Nova. So you go to your Nova database, and you just check what is the host ID, and then from that host ID you check the Nova log file. But this is again time taking and exposing your database and everything to the external world for external troubleshooting, I mean for normal troubleshooting. So that's why when you come here, this OpenStack under cloud has a functionality. It can get receive log from all the nodes, including your controller and all computes on the RSys interface. So you have RSys server and you have RSys client. So these nodes are RSys server and this is your RSys client. Everything comes to this particular instance, and here only in single directory you can see each and every log. So you don't need to log into your OpenStack environment, commercial environment. You can do everything from your under cloud itself. You don't need to log into over cloud. So this is one more advantage of having this under cloud VM. Not VM, but under cloud machine, I can say. This machine can be virtual machine also. It can be bare metal also, depending on the type of installation you are doing. Okay. Any other question?
And Krishna, one more question. It's related to RabbitMQ. Like, if RabbitMQ gets down, then what will happen? Like, all the services will not be communicate with each other, and what will
Yes.
happen to all the instances that are running on hypervisor? Will they be impacted as well?
See, this particular communication is only used when you have a new instance you are creating or you are modifying
Okay.
any resources. If any of your instance is already launched, so it is
Yes.
already running as the on the compute node and already utilizing your networking services. Here, authorization is only required whenever user does any kind of operation. So suppose you want to create a new virtual machine, then only this call flow comes in picture. So definitely your existing VMs will not be impacted or their network services will not be impacted. But yes, if suppose you are doing an operation and at that time your RabbitMQ goes down, then this is a good question that what will happen to your, or suppose if any of the flows get impacted, like you already created an instance and in between, like this particular flow is impacted due to any reason, then what will happen? So one thing to note is that RabbitMQ is a stateless queue. So stateless sorry, stateful, not stateless, stateful. Okay, my mistake. It is stateless, not stateful.
Okay.
So stateless means there are two type of I know, I hope you know the transaction. Two type of transaction are there. One is stateful and one is stateless.
Stateless.
Stateful means that whatever transaction it is doing, it stores its state, whether it is success or fail. But stateless means if a transaction you are doing, it is not going to store the state, and if it fails, then it fails. Then what will happen? User need to retry. So suppose you create an instance and in between any of the flow is broken, then what will happen? It is because it is not storing the state, so this particular flow will be like you can say impacted, and you have to user
Okay.
has to again retry everything. So it will be like retry your complete flow. So here you will get error that unable to fulfill or whatever type of request, and then you have to retry your request again. So it is not a stateful, it is a stateless messaging queue. It is
But
not going to
Krishna,
store.
is there any scenarios where a messaging queue is getting increased or decreased? Like, I don't know, like someone asked me,
Mhm.
if queue gets increased, then what will happen? What does it mean if queue is increasing? Is there something like that with the RabbitMQ? Is
Queue
it
increase.
queue is increasing, like messaging gets stuck
Mhm.
at RabbitMQ and queues get increased? You need to check like something is missing or some, why the queue is getting increased like this, if you are aware of.
As a troubleshooting, like yes, for example, your messages are not getting delivered to the destination, because
Okay,
here what exactly it is doing, it is acting as a postman. So it is
right.
taking your request and sending to destination, and if destination is coming back, this again sending back to your originator. So
Okay.
suppose if it is not able to communicate or any like communication is down between these two things, then
Mm-hmm.
definitely queue is going to increase. So troubleshooting, yes, we have to do, but I will check on this part because
Okay. Okay.
this is like a in-depth topic to be discussed. So I will
All
check and
right.
I will come back to you on this.
Okay, because someone asked me like message if the messaging queue message all the messages are in queue, and
Mm.
if you restart service, then what will happen to those messages that are in queue? New messages will come and they will process accordingly. But what will happen to those messages that were in queue during the like any down or something.
Mm-hmm.
So that
Okay.
was asked during one of the interviews. So if you can
Okay.
in
Okay,
next
sir.
session, okay.
I will take this point in next session. Yes, definitely.
All right.
And
Thank you.
yes, this messaging. See, this Revit MQ is one messaging example. You
Okay.
have other messaging queues also. You have one Kafka also. Even I have not seen Kafka being used in OpenStack, but
Hmm.
just for an example, Kafka is a stateful you can say. So what happens that
Okay.
it takes message from one originator and it's send request to the destination, or destination can subscribe and it can take a message from the Kafka queue. So suppose if in between the queue is like down, the service is down, still has some its cache where it keeps the data information, so that whenever the user again comes, it can get information from there. So
Okay.
these are just like an example of the messaging queue. So we have different open source messaging technologies. RabbitMQ is one of the example. So yes, not only RabbitMQ, you can even implement some other messaging queue also if you
All right.
find suitable for your project.
Okay.
But again,
Okay.
it is part of R&D. Like you have to design an OpenStack for your companies.
All right.
Yes.
Okay. Thank you. Thank you, Krishna.
Okay. Any other questions, guys? No? Okay. So with this, I conclude today's session and we'll meet on next Sunday. So we'll meet on 3rd of April. And till the time,
Okay.
thank you. Thank you everyone for your time. Have a nice weekend. See you. Bye bye.
Thank you, Krishna. Thanks. Bye bye.
Yeah.
Thank you.